Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P16E7 refers to a communication error involving the battery blower linear interchangeable network, LIN. This code occurs when the vehicle's powertrain control module, PCM, detects an issue with the signaling from the battery blower motor. Communication errors can significantly impact the overall functionality of the cooling system, potentially leading to overheating or inadequate cabin temperature control. It's important to understand that the battery blower component plays a critical role in maintaining optimal battery temperatures and ensuring that it operates correctly. This error may stem from electrical issues affecting the connections between the battery fan motor and the PCM, or faulty components in the circuit. As such, a thorough diagnostic process is essential for effective troubleshooting and resolution of the underlying issue. The DTC P16E7 indicates a problem with the communication link of the battery blower through the LIN, or linear interchangeable network. The battery blower is an essential component that helps regulate the temperature of the vehicle's battery. It is monitored by the powertrain control module, PCM, which assesses its operational status through electrical signals. This component is typically located in the battery compartment of the Honda Pilot. If the communications are faulty, the PCM may not receive accurate data concerning the blower's operation, which can lead to other performance issues such as overheating or reduced efficiency. Therefore, properly diagnosing this error is crucial, as it can affect the battery's longevity and overall vehicle performance. When dealing with the DTC P16E7, various potential causes must be taken into consideration. These include poor electrical connections, particularly at the battery fan motor and the powertrain control module, PCM. A shorted LIN wire is another common concern, which can disrupt communication between the components. Additionally, there may be an open circuit within the LIN or IG1 option wiring that can lead to the communication error. The battery fan motor itself can also be faulty, leading to operational issues that trigger the DTC. In rare cases, a defective PCM could be the root cause, resulting in improper monitoring of signals. Each of these factors contributes to the malfunction, making it essential to conduct a thorough inspection and diagnostic evaluation. Symptoms of DTC P16E7 can manifest in several noticeable ways. Drivers may observe warning lights illuminated on the dashboard, indicating an underlying problem with the battery ventilation system or the vehicle's electrical systems. An increase in battery temperature can also be a key symptom, suggesting that the battery blower is not functioning correctly and may jeopardize the battery's integrity. Additionally, the heating, ventilation, and air conditioning (HVAC) performance may be compromised due to inadequate air circulation, leading to an uncomfortable cabin environment. Finally, when using the Honda Diagnostic System, HDS, the presence of this DTC will be evident, signifying an issue that requires immediate attention to ensure both safety and performance. To begin troubleshooting the DTC P16E7, the first step is to turn the vehicle's ignition to the on mode, which powers the vehicle's electrical systems without starting the engine. This is essential for performing electronic diagnostics. After switching to on mode, use the Honda Diagnostic System, HDS, to clear the DTC. This action resets the system, allowing it to detect any current issues without interference from prior fault codes. Following the clearing process, check for any pending or confirmed DTCs within the HDS. If the P16E7 code reappears, it indicates the failure has been duplicated, thus warranting continued troubleshooting. Conversely, if no codes show, it may suggest an intermittent failure, or a temporary glitch in the system that could stem from loose connections or poor wiring. In the second troubleshooting step for DTC P16E7, you will need to switch the vehicle from on to off lock mode. This is important to safely handle the electrical components without the risk of electrical shock or system damage. Next, carefully disconnect the battery fan motor 3P connector, ensuring you take proper care not to damage the connector or wiring. Once disconnected, you will again turn the vehicle to the on mode, preparing to measure electrical parameters. The next task is to measure the voltage between the designated test points across the terminals of the battery fan motor connector. Test point 1 corresponds to terminal number 1, while test point 2 pertains to terminal number 3. If battery voltage is detected at this stage, it confirms that the power supply to the fan motor is intact, and you should proceed to the next troubleshooting step for further diagnosis. The third troubleshooting step involves assessing the integrity of the LIN wire connections. Begin by turning the vehicle back to the off lock mode to ensure safety during testing. With the vehicle off, check for continuity between designated test point number 2 of the battery fan motor 3P connector and body ground. This diagnostic will reveal if the LIN or LIN ACG wire is shorted, resulting in abnormal behavior of the battery blower system. Ensuring continuity will determine if there are any circuit faults between the battery fan motor and the PCM. If continuity exists, it may indicate that the wiring isn't shorted, allowing you to move forward to subsequent steps. If no continuity is found, further investigation is warranted to isolate and fix the issue affecting the LIN signal. During the fourth troubleshooting step, the goal is to identify any potential shorted wires. To start, jump the SCS or SRS communication system line using the HDS and wait for more than 1 minute. This allows for a more stable diagnostic environment for assessing the connection. Next, continue checking for continuity between terminal number 2 of the battery fan motor 3P connector and body ground. While doing this, you will disconnect various connectors sequentially, including PCM connector B, the alternator connector, and the DC-DC converter connector. Monitor whether the continuity changes when you disconnect each of these related connectors. If connectivity is disrupted by disconnecting any specific connector, it indicates that the LIN wire is functioning correctly. Thereby, it suggests other components, such as the disconnected part, could be faulty and in need of replacement. The fifth step in the troubleshooting process revisits continuity checks, specifically for the LIN line. Begin once again by jumping the SCS line using the HDS and allowing for over 1 minute of wait time to stabilize the circuit. Following this, disconnect PCM connector B, which consists of 51 pins, to assess the connection status accurately. You will proceed to check the continuity across designated test points, which are terminal number 2 from the battery fan motor 3P connector and pin number 50 of PCM connector B. This step is crucial, as finding continuity will confirm that the LIN wire is functioning correctly, and you can move on to the next troubleshooting step. If there is no continuity, however, it indicates an open circuit exists between the PCM and the battery fan motor, necessitating repair to restore proper electrical communication. In the sixth step of troubleshooting, the objective is to determine if the battery fan motor is functioning properly. To conduct this test, you will first substitute the existing battery fan motor with a known good replacement. This step is crucial as it will help ascertain whether the original component is the cause of the error code P16E7. Once the known good fan motor is connected, you must ensure that all associated connectors are reconnected properly to restore communication circuits. After confirming all connections, turn the vehicle's ignition to the on mode again and utilize the HDS to clear any existing DTCs in the system. Finally, check once more for pending or confirmed DTCs. If DTC P16E7 reappears, this signifies that the issue may lie within other components of the electrical system, possibly pointing towards the PCM itself. If it does not return, the original battery fan motor needed replacement. Step 7 focuses on assessing the fuses and ensuring the integrity of the IG1 option wire. Start by turning the vehicle's ignition to the off-lock mode to prevent accidental shocks or shorts. Next, check the specified 10-amp fuse, located in the underdash fuse and relay box labeled number C28. This fuse is crucial as it protects the circuit supplying power to the battery fan motor and must be tested for continuity. If the fuse is found to be defective and needs replacement, this will resolve issues linked to the IG1 option wire, which could lead to the DTC P16E7. If the fuse is intact, then the next steps will be to further investigate the wiring connections for shorts or faults that could be affecting the system's performance. In Step 8, you will measure the voltage across specified test points to further evaluate the integrity of the IG1 option wire. Begin by switching the vehicle back to the on mode to power the electrical systems. With the ignition on, measure the voltage between test point number 3 of the battery fan motor 3P connector and body ground. This measurement is critical, as finding battery voltage indicates the IG1 option wire is functioning properly and not interrupted. If battery voltage is indeed present, you will proceed to the final troubleshooting steps. In contrast, a lack of voltage implies that there may be an open circuit affecting the wire leading to the battery fan motor, necessitating repairs to restore proper functionality. The ninth and final step in the troubleshooting process entails checking for continuity in the bat fan ground line. You need to switch the vehicle to the off-lock mode once more for safety. This step is about measuring continuity between designed test points within the battery fan motor 3P connector while it's disconnected. Specifically, you'll be checking between terminal number 1 of the battery fan motor connector and body ground. Confirming continuity means the bat fan ground connection is intact. However, if you find no continuity, it indicates that there is an open circuit in the grounding wire, which will require immediate repair to ensure proper grounding for the battery fan motor. In cases where continuity exists, yet the error persists, replacing the battery fan motor may become necessary, as it could indicate a malfunctioning unit. Once all necessary repairs related to the P16E7 DTC have been performed, it's essential to conduct a final verification to ensure everything has been reassembled properly. Begin by visually inspecting all connections, securing any fasteners, and ensuring that the components are in their correct positions. Once you've confirmed physical reassembly, utilize the Honda Diagnostic System, HDS, to recheck for any present DTCs. The verification doesn't stop here. You also want to execute a road test under normal driving conditions to verify that the battery blower is functioning as intended and that no related fault codes have returned. This comprehensive approach makes certain that all issues have been addressed, providing peace of mind to both the technician and the vehicle owner that the problem has been thoroughly resolved. To avoid future occurrences of DTC P16E7, implementing preventive maintenance practices is highly advisable. Regular inspections of the vehicle's wiring harnesses provide an early warning of potential issues, such as frayed wires or bad connections, which could lead to communication errors. Additionally, maintaining cleanliness around the connectors will prevent corrosion, which can disrupt electrical signals and lead to similar problems. It is also wise to routinely service the battery cooling system, as a well-functioning cooling setup is essential for battery longevity and vehicle performance. Educating vehicle owners on these proactive measures can go a long way in preventing faults and ensuring smooth operation of the vehicle's critical systems. In conclusion, understanding DTC P16E7, which signifies a battery blower LIN communication error, is pivotal for maintaining the performance of the 2016 to 2022 Honda Pilot. Thorough troubleshooting is critical, as each step provides valuable insights into potential issues ranging from wiring faults to component failures. Implementing the outlined procedures helps in isolating the problem and ensuring that all relevant parts function as intended. This not only improves vehicle performance, but also protects against potential damage caused by overheating or poor battery management. Lastly, adhering to preventive maintenance practices solidifies the reliability of vehicle systems, ensuring a positive ownership experience. A well-maintained vehicle ultimately promotes safety, efficiency, and long-term satisfaction. Please like and subscribe to the channel. See you next time!